Welcome to the lesson on area. In this lesson, we will discuss the basics of area and how to solve problems with it. Now, area is the space a two-dimensional closed figure takes up on a two-dimensional plane. There are several formulas to determine the area of numerous known figures, and a lot of these figures we use all the time. For example, if we have a square or a rectangle, we know that the area formula is length times width. If we have a triangle, we know it can be 1/2 base times height. If we have a circle, we use pi r squared. However, not every figure is uniform enough to apply a formula, so sometimes we have to improvise and use several techniques. One of these techniques could be to count units. Now, on this grid, I know that the 1 by 1 square is a 1 square unit. So as I count these square units within this figure, I know that I've counted 26 squares, 26 of these unit squares. So the area of that figure is 26. Now, I could also approach this type of problem even on a unit grid by making rectangles. I know that you can make a rectangle and find its area with length times width. So if I make a rectangle here, I can count 5 units by 3 units and know that this section is 15. And I can do that for the rest of the figure. It's 3 here. I'll say it's 6 units here, 2 by 2, so it's 4 units here. Take this whole chunk, carefully count it. I'll know I'm going to have 7 units by 2 units. So that'll give me 14 units here, and then a nice 9 units here up top. So then I add up those numbers. 15, 3, 6, 4, 14, and 9, and I'll get a total area for my figure of 51 square units. Now, not everything, though, is going to be rectangular. I could have a figure like this, which represents most of the things. Imagine a lake. You want to find the square area of a lake. So what I do here is I can count the whole squares within this figure and count them as 1. So if I count just the ones where the whole square is present, and I know that I have 15 whole squares, not parts, then I can go forward and count just the parts, regardless of how big or small of a part I might have. And again, this will involve a little bit of estimation, but you will see that afterwards you realize that I have 17 parts, and I'll count each part as a half. So 17 halves and 15, and really it does accommodate because some parts are small and some are big. But if I add 17 halves, which is 8.5, and 15, I do get a final answer of 23.5. So you can estimate with a fairly good degree of accuracy that that is 23.5. So let's go ahead and practice with some of these units. And again, I can practice counting all of these units. I'll do so very quickly and carefully. And I get that my answer here is 69 square units. This next problem I'll do by making rectangles. So I'll go ahead and quickly make the rectangles throughout these. I have 4 here, 8 there, 6, 9. This little chunk here will be 3, and then 1, 16. Now I'll pause real quick to state that you can draw these rectangles however you want. It does not have to be how I do it. Either way, you have 10 here, 9, make this little sliver a 6, and this last big part is 18. And after I add all of those together and do so carefully, I get 86. These last problems, I'll do the exact same thing. I'll count the whole parts of 27, count the half parts. I got 16 half parts, and I know I'll get 27 plus 8, and that'll give me a final answer of 35. Let's go ahead and approach the last problem and do the same thing as practice. I carefully do all the little half parts first. Now I have 26 half parts, that'll give me 13. Do all the whole parts in a different color. I have 61 whole parts, so I'll add that together and I get a final answer of 74 square units.